Hello, ladies and gentlemen. Welcome to Chapter 10. We are going to cover today Section 10.1, which is all about square root functions, okay? If you look here, I've already kind of got this first spot filled in about the parent function because I think it really sums up what it is we're going to be looking at. It's y equals the square root of x, okay? And whenever we have a square root of x in our function, much like how x squared gave us a parabola, the square root of x gives us the top half of a sideways parabola. That's what this technically is. We won't get too deep into that for right now, but this shape that forms right here, that's what we're going to be dealing with in this video. So, everything's going to be just looking at different parts of it, namely the domain and range. Now remember, domain is all possible x values, and I'm writing that really small there, and range is all possible y values, okay? That's what domain and range are. And in previous stuff that we've dealt with, right, so like the parabolas, the domain was really easy because it was just always all real numbers. Parabolas go to the left forever and they go to the right forever. But with a square root function or a radical function, they only go in one direction. So we have to kind of look at this little starting point right here. And this starting point can always be determined by h and k. So that's where this guy up here comes in. We call this, it's not really vertex form, but it's kind of vertex form. And we're gonna make one quick edit. It's actually x minus h. We have a typo, go figure. We have to put all this stuff together very quickly. And we miss one plus sign. Cut us some slack if you don't mind. But whatever this h value is here, that's what the h is. That's the x value the x coordinate for this point. And then k is the y coordinate for this point. So in this example, y equals the square root of x, this parent function, h is 0, that's why there's nothing under with the x, and k is also 0, which is why there's nothing outside of the radical sign where h and k are, okay? So with that, the domain is always going to be, at least for the examples we give you, x is greater than or equal to h. And then the range is a little different because these parabolas can go, these radical functions, they can go up forever, which this one will. It'll go up forever and ever and ever. And the reason it goes up forever and ever is because of this a value, right? I know we're kind of hopping around here, but when we look at a radical function and we look at it in terms of these parts, a tells us if it opens up, a is positive, or sometimes, switch colors here, it'll open down, if you can see that pink. That's when a is negative, okay? So when a is negative, let's zoom in here, see this a little better. Okay, when a is negative, it'll go down. So a is usually positive, which means our range will usually be y is greater than or equal to k. And in parentheses, I'll just add a is positive, but it can also be y is less than or equal to k if a is negative. Hopefully you guys like pink, okay? Now, given our circumstances, this is all we're really gonna focus on. There's a little bit more we could do with this, but what we're really gonna focus on is the domain, the range, and then we are gonna look a little bit at how these guys relate to, or how they're transformations of this original y equals square root of x, okay? So we'll kind of be bouncing back and forth a little bit to look at what h does and what k does to a graph, okay? So let's go to number one and we'll just do a few examples, and I think that'll make this a little easier. We have y equals the square root of x plus 3, okay? So what I'm gonna do is I'm gonna rewrite that y equals a square root of x minus h plus k here. And the reason I'm gonna write that is just so I can see it right next to the problem I'm working with. Because one of the first things I'll wanna do is I want to identify what h and k are. H and k is gonna tell me a lot about this graph. So if I look at h is, it's minus whatever's underneath the radical sign with x, but you'll see that the radical sign stops, so there's nothing else with the x, which means that h is 0. Plus k is the number on the outside of the radical that's being added or subtracted on the outside, and here it's plus 3, so I know k is positive 3. Now, what does that tell me? Well, my domain, like we said, h is always greater than or equal to x is always greater than or equal to h. And so my domain is just all numbers x greater than or equal to 0. Okay? My range, I have to think about it. Okay, a is positive 1. The graph is moving upward. So all that tells me that my range will be y is greater than or equal to, and then I just figure out what k is. It's 3. All right. Now, for this last part, it says compare. All right. And what we're trying to do is we're trying to imagine what that parent function looks like. And I'll go back to my pink here. Okay. That parent function started here at 0, 0. And then it went up and over here-ish. Okay. It's going to look something like that. So, assuming I can sketch that perfectly, the only thing that happened to this graph between where it would have started as the parent function and where it ended up, the shape is the same, it just shifted up 3. So all I need to say for the comparison here is just shift up 3. Okay? That's called a transformation. That's something we would normally spend more time on, but for now, we're just going to kind of touch on it because it's one of those things you'll see in geometry and in Algebra 2, and we want you guys to be prepared for next year, okay? So that's all these problems are asking. We're going to do several more of these. Let's try the next one. Number 2, in this one, we have y equals the square root of x minus 1. And again, first and foremost, h is, this is tricky, because we know h is the number under the radical sign, but we also have to remember that it's y equals a square root of x minus h plus k. And that minus h will trip you up because h is actually always the opposite of what you see under here. So if you see minus 1, h is actually just positive 1. And then k is 0. We're not adding anything to the end of it. Okay, so then your domain is now x is greater than or equal to h, which is 1. And then your range is the simple one this time because I'm not adding anything, so k is 0, so y is greater than or equal to 0. Okay, and you can see that in the graph, right? It's never going to go below 0, but it does go up forever. It's never going to go to the left of 1, but it's always going to go to the right. Okay? Now, again, a is positive 1, so that's good to know. We now have to do the comparison. And if we think about that parent graph again, and you don't have to draw this every time, but it starts at 0, 0, up 1 over 1, and then it goes over to here. So while it may look like a lot's happening, really the graph shape is the same, and the only thing that's changing is it's moving to the right 1. H, you'll notice, tells us which direction it's going to move to the left or right, just the same as K, when it was 3, moved it up 3. Okay, so H tells us left and right, K tells us up and down. So for the sake of the comparison, it has shifted right 1. Okay, shift right 1. Now, number 3, it's actually just the same thing but in the opposite direction, okay? Again, H now, opposite of what we see under the radical sign. So now H is negative 1, right? Since it says x plus 1, we know it's actually x minus negative 1. It's always x minus h. So H is negative 1, K is 0 again because we're not adding anything over here. So my domain is now going to be x is greater than or equal to, it's still greater than, we're still moving to the right. X is greater than or equal to -1, but the range, y is greater than or equal to k, is still 0, okay? But now for the comparison, again, imagine you have that original one here, same graph, same shape, but it's moved or shifted left 1. So we would just say shift left 1, okay? Now, number 4, excuse me while I adjust my camera. Number 4, we have A is the only number that changes, right? We don't have an H and a K showing up. There's nothing else underneath the radical sign. There's nothing else after it. So H is 0 and K is 0. But A is 2, which does some interesting things, okay? We haven't had to keep track of A because it's been 1 every time. When A is 2, now what happens to my graph is instead of it looking like this original, well, now it goes up a lot faster, okay? It's like the graph has been stretched, and so we actually are going to call that a vertical stretch. So my domain, nothing changes. X is greater than or equal to H, which is 0. Range, Y is greater than or equal to 0. Y is greater than or equal to K. But then for my comparison now, we have a stretch, okay? It's like we're grabbing that original one and we're just pulling it apart, okay? If you excuse my big hands in the screen. The comparison then here is we call this a vertical stretch of 2. Or sometimes it'll be referred to as a stretch factor of 2, okay? So, vertical stretch of 2 when A is 2. Similarly, on this next example, now A is 1/2. H is still 0, K is still 0. But now A is 1/2. And when A is 1/2, to keep things simple, we'll call that a vertical stretch factor of 1/2. But what actually happens here is the graph gets skinnier. We're compressing it, really. Okay, so my domain will still be X is greater than or equal to K, or H, which is 0. My range will still be Y is greater than or equal to 0, because that's K. But now, a vertical stretch or compression of 1/2. Okay, compression because we're making it thinner, skinnier, kind of like we're pushing down on that original parent function. Okay, and that happens whenever A is a fraction. A is a number bigger than 1, it's a stretch. A is smaller than 1, or it's a fraction, it's a compression, we're squeezing it down. And then for this last example, you kind of get to see everything happen all at once, okay? So here, we'll go left to right here. Here, A is -1, which that's the first time we've seen that. A is -1, H is 2, and K is -1, all right? Now, what this means, again, if we think about that original parent function, this is what the original looks like. It goes up and around like that. Well, this one, it's going down and it's moved over 2 and down 1, right? So it's had a lot of stuff happen to it, which means our domain, same rule, X is greater than or equal to H. H is 2, remember, opposite of what we see underneath, okay? Oops, we can't see that, can you? There we go, okay? H is 2, so X is greater than or equal to 2. Y is greater than or equal to, or sorry, less than or equal to, right? Because now A is negative, and when A is negative, it's less than. So Y is less than or equal to -1 because A is negative. And then for our comparison, there's actually three things, okay? Okay, it shifts down 1, it shifts right 2, and because A is negative, we also say that it flips because now it goes down. The technical word there is a reflection. Okay, and that's just what happens when A is negative, okay? Now, we just covered a lot in that video. This is a really, really good day to reach out and ask questions to us because, again, transformations is something we've usually already spent a couple days on. And so now you're getting that and radical functions in the same video, okay? It's a lot. So reach out to us if you get stuck. Figure at the very least you try for domain and range. And yeah, do your best, all right? Good luck. We'll see you guys around for the next video.